Uh, Question number 6. We have to use the completing a square technique. So we are going to complete the square. So x, then we want half of the x coefficient value. So 2b, half of 2b is 2b divided by 2b. So x plus b square. Then we have to minus b square and plus c equals 0. And x plus b square equal b square minus c. Then x plus b, I am going to take the square root of it. Then x plus b become plus or minus b square minus c. Then x equal plus b to other side minus b plus or minus b square minus c. Just to revise you the way I take this one. So x square plus 2bx plus c equals 0. So x square plus 2bx, then half of this one b I'll add and I'll minus. Then I didn't do any changes to this sum, and this is going to be x plus b square minus b square plus c equals 0. X plus b square minus c, then x plus b equal plus or minus square root b minus c. Question number 7. We'll start with the left hand side. I can write this one as x minus 2 over x times x minus 2 over x square. So we'll leave as it is. This one I can write x square minus 2 times x times 2 over x plus 2 over x square. Then let me do it differently, otherwise you will get confused. First term is x square. It is plus x. First term, there are two terms. One is plus x, other one is minus 2 over x. Then the first term we will get when you x square this one. The last term we will get when you x square this one. The middle term we will get 2 times of this one. 2 times of this term and the middle term. So this is going to be x square, this is going to be 4 over x square, and this is going to be minus times, sorry, this is plus x. Plus x times minus 2 over x. This is going to be minus 4 over minus 4. X to x cancel out. Minus 4. X square minus 4 plus 4 over x square. Then I am expanding this one from, first of all, from the x times x square minus 4 plus 4 over x. I am expanding plus 1. Other term is minus 2 over x times x square minus 4 plus 4 over x square. Now this is going to be x cube 4x plus 4 over x. This x square and x cancel out. You can write 4 over x square times x. This is cancel out 4 over x. This is going to be minus 2x minus 9 times positive 8 over x. And this is going to be minus 8x cube. Now let's see. X cube is here. Minus 2x, this one minus 6x. All took. So this is 4 over x, 8 over x, which is 4 over x, 8 over x. Denominator is same. 4 plus 8, 12 over x. 12 over x. And this is 8x cube. Question number 8, we'll take LHS equal, I'll take this is plus x cube times, I'll multiply by this one, then plus minus 1x, sorry, minus 1 over x, then again I will multiply by this one. This is going to be x cube times x 3 over 2 plus x cube times x minus 5 over 2 minus, okay, I'll bring this one up, x minus 1 times x 3 over 2 plus x minus 5 over 2. This is going to be x 3 plus 3 over 2 x 3 minus 5 over 2. This is going to be x minus 1 times x 3 over 2 plus x minus 1 times x 5 over 2. So this is going to be x 9 over 2 plus this is going to be x 1 over 2. This is going to be minus x minus 1 plus 3 over 2 and x minus 1 minus 5 over 2. This is x 9 over 2 plus x half minus x 1 over 2 plus x minus 7 over 2. So minus half and plus half cancel out. X 9 over 2 plus x minus 7 over 2. Now x times 9 over 2 plus 1 over x 7 over 2. Now I want to bring x half out. Now this is going to be x 9 divided by 4.5 and plus x, this is 3.5. Now I need x half I want to take out, but there is no x half in the top. So then I'll make 0.5 x 4.5 plus x 0.5 and x 3.5 and divide by x 0.5 because I introduce x 0.5 to up, so then it has to be cancel out. So this one cancel out. I didn't still x here 3.5. It's like this. Now for example, if you want to this is 2 If I multiply a and divide a, still this is 2 because this is cancelled out. Likewise, I multiply by zero point 0.5 and divide by x to the power 0.5. So that's what I did over there. Now, why I did? Because I want to take x 0.5. X half mean x 0.5 x4 minus 1 over x4. Now I can write x4 times x 0.5 plus x 0.5 over x 3.5 plus zero point 0.5. Now I can take zero point 0.5 out. This is going to be x4 and this is going to be remain 1 x4 x 0.5 out, and this is going to be x 3.5 plus point x4. X 0.5 mean x to the power half. So x4 1 x4. Without points also you can work out x 9 over 2 plus x minus 7 over 2. Then what you could do, take x 9 over when you take half out, this is x 8 over 2, which is 4, and this is going to be x minus 7 over 2 times x minus half. It means x half a times x4 over x4. Sorry, this is not minus, this is x half. Also, I work differently this one. Now x half is missing, right? I'll multiply by half and divide by half. X 9 over 2 plus x minus 7 over 2. Now what I'm going to do, I'll leave this one. I came up to here, and there is 1. 1 I can write a over a also 1. 3 over 3 also 1. X to the power 3 divided by x to the power 3 also 1. Because we see cancel out, right? X half divided by x half also 1. So I use x half over x half. Then I keep this first x half and I multiply by this one inside. So x1 over, I'll keep this one, x 9 over 2 multiply by x half, and I will bring it to down x 7 over 2 this one, and times x half. Now this is x half, this is going to be x 9 over 2 minus 1 half, plus this is going to be x 7 over 2 plus half. It means this is x half, this is x 4 and 1 over x4. I want to show that this is positive for 3n square minus 4n plus 10. So I will take 3 out. N square minus 4 over 3n plus 10 over 3. So when you multiply, you can get this answer. Now keep in 3, we'll start completing the square. N minus half of 4 over 3, which is 2 over 3. square minus 2 over 3 square plus 10 over 3. So 3 times n minus 2 over 3 square minus 4 over 9 plus 10 over 3. So this is going to be 3 times n minus 2 over 3x square minus, so what is the answer? 4 over 9 plus 10 over 3. So multiply by 3 both up and down, minus 4 over 9 minus 30 over 9. I made denominator same, then 30 minus 4, 26 over 9. So this is plus 26 over 9. So this is plus 26 over 9. Then we'll take multiply this one, 3 times 9 n2 over 3 square, then 3 times 26 over 9, 3 to 3 cancel out, it will become 26 over 3. Now we want to show that completing the, for that for all value of n this is positive. Now we want to show that this is positive for all n. What is this one? It's a polynomial, or the in terms of, if I make to a graph this one, I can write this is a as fn, function of n. Now it is same as fx equal 3x square minus 4x plus 10. So this is n axis and this is fn, right? Now n minus 2 over 3 equals 0, n equal 2 over 3. So n equal 2 over 3 is the symmetric line. Then plus 26 over 3 is this is minimum because positive the square value. This is 26 over y equal, it's 26 over 3. Fn, no, I'll write y or fn, and the curve goes from here. So we want to show this expression is positive. It means this y value is y for all x values. This y has to be positive. So you can see that all the y values, you can see that the graph start from here upward 26. It means all fn positive for any value. Hence you can write minimum value is 26 over 3. Hence fn or 3n square minus 4n plus 10 for all the domain values of n. This is n is for whole mean if n is all real numbers. If n is positive real numbers, then graph is going to be, this is f is for whole real numbers. If it is fn is for positive real numbers, you can't get this graph here, this part. Actually, up to here you can get all positive value of x and that's all. It's not going up from to negative n values, but it will move like this. I'll give argument form now. I'll give argument. I'm going to tell that this is positive, hence this one is positive. Right. N is any number, so it can be positive or zero or negative. Now I will take 2 minus out from here. Still this one, according to the n is bigger larger number, it is positive, n is 0 negative, n is 2 over 3, it is 0. I'll discuss again. If n is 1000, so 1000 minus 2 over 3 greater than 0. If n is 2 over 3, 2 over 3 minus 2 over 3 is 0. N is 0. Then 0 minus 2 over 3 is less than 0, or n is minus 2 minus 2 minus 2 over 3 less than 0. So all the possibilities is still greater than 0, equal 0, less than 0. But if I square this one, it has to be greater than equal to 0, no more. Then I will add to 26 over 9 to both sides. Add 26 over 3 to, sorry, another one, 3. I missed 3. Then 3 times n minus 2 over 3 square is 0 times 3. 3 greater than 0, I multiply. Then what you can tell? This is also greater than 0. Now I am going to add 26 over to both sides. Add 26 plus over 3 to both sides. Then 3 times n minus 2 over 3 square plus 26 over 3 is greater than or equal to, this is greater than or equal to 26 plus 3. 26 mean 3 times 8, let's say 8. It is greater than to 8. If it is greater than to 8 mean it is definitely greater than to 0. Then this expression is greater than 0. This expression is greater than 0 mean this expression is greater than 0. Then this expression is greater than 0. Hence this expression is greater than 0. Hence this expression is greater than 0. Hence this expression is what? Hence 3n square. We have to write like this backward. 3 times n minus 2 over 3 square 26 over 9 greater than 0. Then what else? Then this one. 3 times n minus 2 over 3 square minus 4 over 9 plus 10 over 3 greater than or equal to 0. Right, likewise then this one, finally you can write I will write here then from here to here, then n minus this one 3 times n minus 2 over 3 square minus 2 over 3 square plus 10 over 3 greater than or equal to 0. Hence 3 times n square minus 4 3n plus 10 over 3 greater than or equal to 0. Hence 3n square minus 4n plus 10 greater than or equal to 0. So this is how you want to write. Actually, when you come to this level, right, it is still okay, right? You show that this one is greater than equal to 0, and then finally you can void middle step. Hence 3n minus 4n plus 10 is greater than, this means this greater than 0. If you really write, you have to go back and write, but this is also acceptable. This one, this one, this one, this mean what? This one. Question number 10, we want to show that this is negative. We want to show that this is negative for all values. Okay, if I take fn, and if you show the graph that I believe or something like this or something like that or something like that, but all fn value should be, y value should be negative. So we last with the completing the square. I'll take minus 1 out, n square plus 2n plus 3. Now, okay, minus out is still the same rather than minus. We know this is going to have a maximum because the value of a of this quadratic equation is negative. Now, keeping this one, n plus 1 square minus 1 square plus 3 minus n plus 1 square, this is going to be minus 1 plus 3 plus 2. Now I'll take the minus out, minus n plus 1 square minus 2. You can see that maximum y value is at minus 2, right? If we consider this graph, it means this is same as minus n plus 1 square minus 2. So n equal minus 1 is the symmetric line, and n y equal this is, let's say, y equal minus 2. So this point is minus 1 minus 2. So graph is going like this. Hence all the maximum is at minus 2. Hence fn is negative for all. Fn we introduced by ourselves, so we can't write Fn. Minus n square minus 2n plus 3 is negative for all values of n. Whatever the u value, put the graph move like this. If I give the argument, I can give n plus 1. If you take any value from number line n, this n can be greater than 0, equal to 0. When you take n number line, 0, 1, minus 1.1, likewise, it can be 3, either positive, negative or 0. Then I add 1, still positive, negative is 0. Then when I square this one, it is greater than or equal to 0. Then if I multiply by negative value, then it is less than 0, because it will flip. When you multiply or divide by a minus number, the sign will change. Sign is change. Now minus n plus 1 square minus 2. I add minus 2 to both sides. 0 minus 2. It means it is less than minus 2. So this expression definitely less than minus 2. It means it is less than 0 guaranteed. Right? When you look at this one, some values is less than minus 2 mean it is definitely less than 0, because 0 is much above. So hence minus 1 n plus 1 minus 2 less than 0. It means this value is negative for all the values. So hence I rank this one. Hence this is one step, second step, third step, fourth step, fifth step, sixth, seventh. Hence, okay, this is sixth step, seventh step. So you don't need this one. Okay, I will write this is 7 again. Then what is the eighth step going to be? This one. Then ninth step going to be this one. Then 10th step going to be this one. And the 11th step going to be this one. Now you write like this, and hence finally you are writing after 11 dot dot dot, after 11 you are writing after 10 basically. This is 11. You don't need 11 actually. After 10 you are writing 7 to 10. Then 11th step you are writing hence minus n square minus 2n minus 3 less than 0. Hence expression is negative for all values, all negative values. Sorry, expression is negative for all values of n. But usually it is enough when you come to this level. Minus n plus minus 2 less than 0, you come in like this. And you can, without going 10, 7, 8, 9, 10, straight away you can jump to 11. Right? Hence, minus n square minus 2n minus 3 less than 0. Then you can write hence the expression is negative for all values of n. Question number 11, same type of question. We want to show that x square plus 8x plus 20 greater than equal to 4. X square plus 8x plus 20 minus 4 greater than equal to 0. X square plus 8x plus 16 greater than or equal to 0. I'm going to complete this square. X plus 4 square minus 4 square plus 16 greater than equal to 0. X plus 4x square, this is minus 16 plus 16 greater than equal to 0. It means x plus 4x square greater than or equal to 0. We'll give argument for this one. So when you take the number line, this is x, all x. All x can be either negative or equal to 0 or positive. So I'll write x can be either greater than 0, equal to 0, less than 0. When you add 4 to this one, definitely greater than 4, it means this is greater than or equal to 0. Even not equal to 0, when you add plus 4, this is greater than 4. This expression is greater than 4. It means it is definitely greater than to 0, not even equal. So then x plus 4, sorry, no, I have to give again. X plus 4. Also when you add greater than equal to 0, because uh, this is according to the x value, big X values, the small x values are still going to be the same, stay with the same. But x plus 4 square is greater than or equal to 0. Hence, x plus 4 square, when you add, yes, that's all. X plus 4x square greater than or equal to 0, like this. It means it's moving to here. I'll come to here. X square plus 8x plus 16 greater than equal to 0. If this is, I give argument, because when we x square, always it is positive. It means this one. This means this. X square minus 8 plus 20 minus 4 greater than or equal to 0. This is going to be hence x square plus 8x plus 20 greater than equal to 4. So this is the argument. X greater than or equal to 4, x plus 4 also same. When you square it, we will lose the negatives, and this means this. Then this means this, and this means this. Or the second method is, if this is fx, we have to draw the graph. So this is x minus 4, and it has a minimum. This is a minimum graph. So it can be 0 as well here. So from the graph, the minimum value is 0. So you can write from the graph, the minimum value is you can tell from the graph the minimum value for x plus 4 square is 0. It means x plus 4 square greater than or equal to 0. Right? X plus 4 square means this one. Right? It means x square plus 8x plus 16 greater than or equal to 0. Then we have to add 4 to both sides. In x square plus 8x plus 16 plus 4 greater than or equal to 4. Right? Hence, x square plus 8x, this is going to be 20 greater than or equal to 4. So question number 12. This equation has no real roots. It means this equation means this is fx, y value. This values, addition of these values represented by fx curve. It means this curve, whatever it is, it doesn't crosses the x-axis. It means to become this one, we know that b square minus 4ac has to be less than 0. Now a equal k, b equal 5k, c equals 3. So b square mean 5k square minus 4 times a times c is 3 less than 0. So this is going to be 25k square minus 12k less than 0. I can factorize this one. K 25k minus 12 less than 0. Now k is a constant. K is a constant. Assume k equal 100. Then what is this answer? 100 times 250 minus 12. This means 100 times 238. 28,800. Is it less than 0? No. Then you want to find the k values, special k values, which satisfy this inequality. We know that k equal 100 doesn't work, right? But some value works. So what are those values? If we put points 001, I think it should work. K equals, so this is 0.001. This is going to be 0.25 minus 12. Yeah, this is going to be a negative number. Then how do you decide what is the area? Now we have, we'll consider this one. K equal 25k minus 12 equals 0. then k equals 0 or k equal 12 over 25. It means this number line you are categorized into threes. One is 0 and another one is 12 over 5. So we have three areas, k value less than 0, this area, or k value in between 0 greater than k greater than 12 over 5, and then the other area is uh, k greater than 12 over 5, this area. Now what you could do, simply take a value from this area, and this area, right? And substitute and find the numbers. That is one way. So if k equal, tell me any value less than 0, minus 1, this expression, right? Minus 1 times 25 minus 1 minus 12 is, this is going to be greater than 0 when you simplify. Okay, we'll simplify and see. So this is going to be minus 1, 20, this is going to be minus 25, this is going to be minus 12, then this is minus 1 times minus 37, minus times minus positive. So this area doesn't work. Then, so we want to tell this story. When k equal minus 1, minus 1 times 25 minus 1 minus 12 is greater than 0. Then k equals, now pick up a value from this area. When k equal this is 12 over 25. If I take 0.001, it works. It works. So 0.001, 25 times 0.001 minus 12 less than 0. Then that is work. This is not. This is work, and this one now. Something greater than, let's say, 1. When k equal 1, 1 times 25 minus 12 is greater than 0. That doesn't work now. So only the satisfied area is 1, this one. Hence you have to answer 0 greater than k greater than 12 over 5 is the, hence 0 greater than k greater than 12 over 5 is the required area. So you have to do this calculation and show that you pick up a value from k equal this area, right? K equal minus 1. Then you pick up a value from 0.001. You have to convince your argument, and you have to take k equal 1. And then this is not wrong, this is wrong, this is the only relevant area. If you put a value to this, if you put a value, k value in between this expression, this quadratic equation will never touch the x-axis, no real root. But if you put any values in this area, there are roots. So the other method you can show this one. So now this one, when you consider this one, FK graph. What is the FK graph? This one. 25k square minus 12k, or k times 25k minus 12. So you want to show this one. So what are the root of this graph? We found out when it is equal to k equals 0. Another one is, and graph is a this is a positive value. It means it has a minimum. Graph is going like this. So you can see that this fk is negative from this is 0, this is 5 over 12, sorry, 12 over 25. This graph is negative in from here to here in terms of x from here to here. So you have to draw this graph, and this is which axis? K axis. This is fk axis, right? Then you have to tell according to the graph fk is negative in between 0 greater than k greater than 12 or 25. So fk mean what? This one. Hence you can tell that kx square plus 5k x graph 3 has no real root when between 0 and 12 over 25, or bracket 0 greater than 12 over 25. Now when you have this kind of one, we have to carefully check two things. One is this value, especially k, those two values. What will happen when you have a k equals 0, and so we talk about the values in between, right? Now what will happen? K equals 0 and k equal 12 over 25. In here you can see that there's a equal sign in the question, so then you have to give a argument for that. So what you could do, you can select k equals 0 and substitute here and see the possibilities, right? Now kx square plus 5kx plus 3 equals 0. When k equals 0, this is going to be 0 plus 0 plus 3 equals 0. It means LHS not RHS. It's impossible. For k equals 0, this doesn't uh, match. If you put k equal 5, it is depend on x values. But when I put k equals 0, I can freeze this one. I can freeze, or I can get rid of x. Then it is totally, this is a special value I can check. So straight away without the help of x. So k equals 0, it doesn't satisfy. Hence k or equals 0 also. Hence k equals 0 also has no k equals 0 does not provide real roots. Hence answer is 0 k greater than or equal to 12 over 25. In my previous discussion also, you have to consider that one k equals 0. The same way, in my previous discussion, I think I use uh, bring it to number line, and this is less than, and this is k equals 0, and this is in between. So I'll check, I can remember, I think minus 1, k equal 0.001, and k equal 1. So we check these ones, and then we came to a conclusion 0 greater than k greater than 12 over 25. Then you have to check this one again, k equals 0, and then come to a conclusion like this. So question number 13. So this is also same. So has two distinct real roots. Prove that if this I have two distinct real roots, b square minus 4ac has to be greater than 0. So b square means a is p, b is minus 5, and c is minus 6. So b square minus 4ac, b square means minus 5 square minus 4 times a times c is minus 6 less than greater than 0. So 25 minus plus 24 p greater than 0. So 24p greater than minus 25, p greater than minus 25 over 24. That's all on this one. Let's name this number line. This number line is p number line, not x. In 25 over 4, right? This is 25 over 4 value. So if the value not equal, either less than, so you have to put this is the no, p has to be greater than, right? That's why. So this is the area. Without this value, if you select p greater than this value, then this equation is satisfied.